Okay, I got cut off there. Ran out of time on that one. Okay, so we've added these together here. We've added the whole numbers together. Now we need to add the fractional pieces together. I remember saying that the common denominator was 18. So let's make equivalent fractions out of these right here that all have denominators of 18. All right? So in order to turn the 2 to 18, I have to multiply by 9. So I'm going to do the same up here. 9/18 is the same as 1/2. To turn the 3 into 18, I have to multiply by 6, so I have to do that to the top also. What you do to the bottom, you better do to the top. So we get 12/18 here, and down here I have to multiply 9 by 2 to get 18. So I'm going to multiply 7 by 2 and get 14. All right? Now that our denominators are the same, I've got 9/18 here of a whole, 12/18 here of a whole, and 14/18 of a whole right there. I need to add all those fractional pieces together. Okay? So 12 plus 9 is 21, plus that extra 14, that gives you 35. So I get 35/18. So far, I know my answer is 86 and 35/18. So what do you think about that answer? Yeah, we've got an improper fraction happening here, and we don't leave our answer like that with an improper fraction in it. So we're going to have to go ahead and change this piece right here, that improper fraction, to a mixed number. So I need to know, and what this says is it says 35 divided by 18. It says this, 35 divided by 18. How many times does 18 go into 35? Well, it goes into 36 twice. So it goes in there once. That's 18 when you multiply. Let's subtract. Carry. That's going to be a 7 and a 1. So that turns out to be 1 and 7/18 for this improper fraction, which we have to add to our 86. So our final answer is 87 and 7/18. Okay? Got that one? All right, let's move on. Number 9 is always going to be a whole number subtracting a mixed number. And before I do this problem, I want to show you a simpler one, okay? Because the process is exactly the same. Okay, my computer's being slow. All right, let's say we've got this problem here. We've got 3, and we're going to subtract 1 3/4, okay? Well, if I had 3 subtract 1, the answer's 2. But I have to subtract another 3/4. And I know some of you already know the answer, but I want to show you a visual of what's happening here. So I've got my 3 wholes, and I'm subtracting 1. So let's knock off that 1 right there. But I'm also removing another 3/4. So what I need to do, since these are wholes, is I need to borrow one of the wholes and break it up into 4 equal pieces. Okay, you see what we did there? So once the whole is broken up into 4 equal pieces, then I can remove 3/4. So that 1 whole is the same as 4/4. So what I did mathematically is, of the 3, I took 1 and busted it up. When I take this 1, I've got 2 wholes remaining, but I'm going to bust it up and call it 4/4. 2 and 4/4 is just another name for 3. Okay? So now I can take the 2 and subtract 1 and get this 1 whole right here. And I can take this 4/4 right here and remove 3/4 from it. So we're going to take that one and take that one away and take that one away, and I'm left with 1/4. Okay? So let's go back to that original problem. We're going to do the same thing here. We need to borrow a whole, since we have a whole number and we're subtracting a mixed number. It's real easy to take 46 and subtract 4, you get 42. But I also need to subtract another 2/7. So I'm going to borrow a whole from the 46, and now I'm going to call it 45. It's going to be 45 plus another whole, and your whole is determined by that guy right there. 7/7 since 7/7 is another name for 1, when you add it back to 45, you get the 46 we started off with. Okay, so that one whole that we borrowed, I'm going to call it what? Yeah, we're going to call that one whole I borrowed 7/7. Now I've got I've got a whole that's been busted up into 7 equal pieces, and I can remove 2 of them. So 45 subtract 4 is 41, and 7/7 subtract 2/7 is 5/7. All right. If I need to pause the video, you guys just let me know and I'll do that, okay? 10 is always going to be a subtraction of mixed numbers problem, and most of them are going to be way easier than this. So if you guys can do this difficult problem, you should be able to handle those easier problems I'll be throwing at you this year. Okay, let's see. First thing we need to do, if we're going to subtract, what's the first thing we need to do? Yeah, we need common denominators. Between 1/5 and 2/3, what's your common denominator? Yeah, 15. So, what'd you multiply 5 by to turn it into 15? Yep, so I got to do that up here. 1/5 is the same as 3/15. 2/3 is the same as how many 15ths? Well, what did you multiply the 3 by to turn it into 15? Yep, I got to multiply the numerator by that also. So I get 10/15. Now, 74 and 3/15 subtract 61 and 10/15. Problem here is I got to take the 3/15 and subtract 10/15, which if I do that, that's going to give me a negative fraction. Not so certain I want to do that. So what I can do is what we did with number 9. I can borrow a whole from this one, call that 73, and I'm going to bust that whole up into how many equal pieces? Yeah, I'm going to put it over here and add it to this piece here. And I'm going to call it 15/15. Tell me again why I'm calling it 15/15. Yeah, because our denominator is 15. Okay, so 3/15 plus that whole that I busted up gives me 18/15. What is 18/15? Now subtract 10/15. I get 8/15. I got to take the 73 and subtract the 61. So 3 subtract 1 is 2, and the 7 subtract the 6 is 1, and there's our final answer. Okay, that one looks scary, but that's not that hard, is it? If it is, I promise we'll practice it some more. All right, moving on. Okay, before we do this one, I want to make an estimate. And actually, I think what I'm going to do is I'm going to make a range of estimates that I think this answer is. Okay, and I'm going to do it this way. I'm going to round both of these and then multiply and see what I get. 1 and 1/3 rounds which way? Yeah, it rounds down to 1. And 2 and 3/4 rounds to what? Yeah, that rounds to 3. So I would say on the high end, well, maybe 3. Let's put 3 here in its own separate little cloud. If I rounded this up to 2, I know definitely on the high end the answer's 6. Okay, I definitely know my answer is not 6 because I rounded both of those up. 6 is too high. All right, I'm thinking it's more like 3 maybe. If I round both of these down, I have 1 times 2, which is 2, and I know that's too low. So put that in there. I'm really thinking my answer should be somewhere around 3. All right, so let's do the math. All right, multiplying fractions is no problem. Tops times tops and bottoms times bottoms. And I hope you all know why that works. But if you've got mixed numbers, you've got to change them to improper first. Okay? 1 is 3/3 plus another 1/3 gives you 4/3. 1 and 1/3 is the same as 4/3. The trick is, or the shortcut is to take 3 times 1 and then add this 1 to it. Okay? 2 3/4. Well, 2 is the same as how many fourths? Yeah, 2 is the same as 8/4. Plus another 3/4 gives you 11/4. What's the shortcut in getting that? Yeah, take the 4 times the 2 and add 3 to it. All right, now we can take our tops times tops and bottoms times bottoms. 4 times 11 over 3 times 4. And I know a bunch of you are going to go ahead and do this and then reduce. But what I do is I see that there's a 4 in the numerator and there's a 4 in the denominator, and I know those will cancel each other out, giving me 11/3. Up here, you guys are going to divide by 4 and get the same thing. And then we have to change this back to a mixed number. 11 divided by 3. 11 divided by 3. 3 goes into 11 3 times. That's 9. When you subtract, you get 2. So our answer is 3 wholes and another 2/3 of another whole. All right. Woo! Let's see if we can get in 12 before the time runs out. We've got division. 12 is always division with mixed numbers. Okay, let's make a little, oh, by the way, what was our estimate back here? Didn't I say our estimate was 3? I think my answer is reasonable. All right, forgot to check that. Let's do another little estimate here. If I call this, well, 4.5, let's call it 4 divided by 1. I get 4. What if I round that? I wouldn't round that up, but what if you called this 4 and divided it by 2, rounded it up? You get 2. What if I rounded this up to 5 and divided by 1? I'm rounding that down. I get 5. What if I call this 5 divided by, round that up and call it 2? I get 2.5. All right? So my high and my high is 5 and my low is 2. I'm going to predict my answer somewhere at about 4, roughly about 4. Okay? And this is what I see a lot of kids not doing and coming up with really crazy answers. All right, dividing fractions is easy as pie. Flip the second one and multiply, but you have to change these improper first. So 4 times 2 plus 1, 9 halves, divided by 8 times 1 plus 3, so that's 8, 9, 10, 11 eighths. Dividing fractions is easy as pie. Flip the second one and multiply. All right. How do you multiply fractions? Tops times tops. Bottoms times bottoms. All right. Now I'm sure what you guys are doing is just multiplying straight across. What I'm looking here, myself, I'm looking to see if there's anything that will cross cancel. Once you've got one fraction, you can look for cross canceling, and it'll happen right here. 2 goes into itself once, 2 goes into 8 4 times. Now when I multiply, I get 36 over 11. So this says 36 divided by 11. 36 goes in the house, 11 goes out here. 11 goes into 36 3 times. Subtract. All right, so leave your answer like that. Your answer is 3 wholes and another 3/11ths of another whole. Does that match our prediction or our estimate? Yeah, it's pretty close. I knew it was, I knew it was going to be somewhere in there between 2 and 5. So I like my answer. I think it's good.